Hey everyone, in this video I'm going to be going over a book that I've recently completed. This is Mathematics for Machine Learning by Deisenroth, Faisal and Ong. So I'm going to go over in this video what the book is, who it's for, who would benefit most from it, what kind of prerequisites you need to read it, what you can expect out of it, essentially, like, is this the right option for you, given your goals and given what you want to get out of machine learning? So, the book is split into two sections. The first part goes over math, like actual theory, solved problems in linear algebra, in calculus. A lot of it is also in like niches of linear algebra, like matrix decompositions and whatnot. And there's also a section on probability and statistics. Second part of the book, they basically take in 3 concrete machine learning problems and use the math from the book to solve those. And what I like about it is that they do include on their website 3 Python notebooks that you can actually use to, or essentially they've coded them from scratch and you fill in the gaps. You fill in like the implementation. Now, the first question when it comes to having a book like this is whether math is even important in machine learning. Because the thing is, nowadays we do have a lot of deep learning frameworks like PyTorch, JAX, and whatnot. So people think like, okay, what's the point of understanding the math behind it if the computer's doing all of it? The thing is that oftentimes in machine learning, in deep learning, you're not just going to download some kind of model and then use it on the exact same data that they used it on, or you're not going to use it for the exact same purpose. You're going to want to modify it or its data. And if you don't really understand how it's working, then you're going to run into some problems. You're pretty much almost guaranteed to fall into some broadcast errors or dimension incompatibility errors. The first one is going to be if you try to do an element-wise multiplication, addition, or subtraction with matrices that the dimensions don't match. That's a broadcast error. And the second one is going to be if you try to multiply 2 matrices, not element-wise, but standard matrix multiplication, and the dimensions don't match, you're going to have a problem with that. And the thing is that those kinds of errors are pretty easy. It's easy to see why you're getting them. You can see that the dimensions are wrong, but then, okay, what is the correct? How do I transform data so that it's correct? Or how do I? What step am I missing here? Like, what is it supposed to be doing? And the thing is, if you go ahead and look at some NumPy code where they're squeezing tensors, they're getting inner products on them, they're flattening them, they're reshaping them, that's usually based on some specific instructions in a paper, some specific mathematical instructions. And you have to understand the math behind it in order to know what it's supposed to be doing. Because oftentimes you'll look at some Python code and you just see a bunch of tensor operations going on, but you don't know exactly why each step is doing what it's doing, or how it necessarily works. You have to go to the paper for that, and the paper is all going to be math and machine learning prerequisites. So understanding math and machine learning itself, rather than just instantly going and downloading some framework or some library, some code off of GitHub that trains for you, like a Python notebook that does all the training and inference for you. Realistically, you're going to want to use your own data. You might want to modify the model itself to run on a mobile device or deploy it in some other way, and you have to understand how it works. In order to do that, to understand how it works, you have to understand the paper, and the paper has math and machine. As far as prerequisites are concerned, I'll give you some examples of things that you would not have been able to find out unless you would have those prerequisites. So for example, on page 123, we have the derivative of a polynomial. It goes from here, and then it goes to here. You would not have been able to understand what this is or why they did it unless you knew that you recognize that it's a binomial theorem from pre-calculus. So that's the thing. If you have no experience in calculus, you never took pre-calculus, there's going to be some concepts here that you won't understand what they are or how they work or how they got there. Another example, on this time actually on page 323. Essentially, the covariance update of a Gaussian mixture model, and it's going to show why the update of a Gaussian covariance, which is this, how they got there. In which case they start off with computing this partial derivative, and they go through quite a bit of derivation and all kinds of other operations until they finally get to the actual update step itself. So if you don't understand calculus or you don't have a good grasp of algebra, then you're going to be very confused as to the proofs here. And that is like a common theme. A lot of times the proofs are going to cause problems if you don't have any experience in the area. So that being said, you don't have to understand how everything was proved. Like for example, you could just take this, put it into the Jupyter notebook, and have a working Gaussian mixture model. You don't have to know how it was derived. So the book is still a good read, even if you can't follow the proofs. It's just something to keep in mind when you start. It is a rigorous math textbook, and there are going to be areas where you'll probably get stuck. I was not able to solve even half of the problems, to be honest. But it is still a very good introduction to where essentially before you might see something in machine learning, you might see something like a loss function, you might see a concept like Gaussian elimination, or you might hear about maximum likelihood estimation, or you might hear about eigenvectors, singular value decomposition, and you won't even know what that is. You might not be able to recognize it. Now you can. Now essentially you at least know where it is, where it fits into math, where it fits into machine learning, and where to go if you really need to get it into detail. So even if you don't understand all the proofs, you can't solve all the problems, being familiar with the math for machine learning is still a really big asset to have, especially if you want to understand papers, especially if you want to modify other people's code, which is usually based on a paper. This is really good for that. One other great thing about this book is that it is in many ways a community project. First of all, it's available for free, unless you get the print version like me, which I do recommend because it's nice to have a print version. But it is available on their GitHub. They have people on the GitHub actively pointing out any kind of errors or misunderstandings. The authors have not commented on every GitHub issue. In fact, lately it seems like there are a lot that are outstanding, but it's still great that they have a community around the book. Which brings me to another point, is that this book does have exercises, but there are no solutions to the exercises. But given how it's starting to become, it's essentially become the go-to for machine learning math, you can find solutions online. So you can see, for example, this GitHub user has created solutions to the exercises here. You can find them very well done, very well spelled out. So that's another big plus, is that you do essentially have solutions through the community because there is a community around the book. Now, given that the book says that it requires math that is commonly found in high school, that is technically the case. Essentially, yeah, you do need to have seen derivatives and integrals before and have solved some. To be honest, that is a fairly liberal set of requirements, because in reality, this book is more well suited to someone who is either a graduate or undergraduate, advanced undergraduate, and it reads more as like you've already taken courses in statistics, in linear algebra, in calculus, but you just want to sort of brush up on the parts that are relevant to machine learning. So it's not going to go over all of them in detail, but it will show you at least, first of all, what you need to know, because for example, you don't need to know all of Calc 1, 2, and 3 for machine learning. This book will tell you which parts of it you need. So if you don't know them, you at least know what to study and what to read up on. And otherwise, for people who have taken them, they can just brush up on the parts that are relevant. That's more where the book is suited for. If you're, let's say, a regular software developer or an undergraduate who is not related to any STEM field, it's going to be a very challenging read, but you can still get plenty out of it. So overall, I guess the main question is, do I recommend reading mathematics for machine learning? I'm going to go with a yes, because in machine learning, there are going to be a lot of situations where you have to go through research papers in order to modify or edit what's in the code. In order to understand the papers, you have to understand general machine learning algorithms, and you also have to understand the math behind them. You have to understand the math to get the paper, and you get the paper to understand the code. I can imagine that most of the math in the book, you probably won't necessarily need to like solve an equation. You probably won't need to solve a derivative on the board while you're doing any kind of machine learning problems. And you probably can skip most of the proofs, because essentially you're just going to be implementing things. But you do want to understand how things work at a fundamental level. You want to know, like, for example, if you're in a Gaussian mixture model, what exactly is a PDF, understanding that the parameters are the means and the covariance, and that the data isn't an actual parameter, you're just fitting it to the data. You have to understand these concepts, and even if you don't have all the prerequisites, just being familiar with it, just having seen it before, just knowing where it is, how it fits into the bigger picture, having seen some examples of it used in machine learning algorithms, I think it's a huge asset, and I can't imagine it being a waste of time to spend like 1 or a couple months going through the book, going through the math, just to have that under your belt and being more well prepared to solve just a wider range of problems than you would be if you didn't have any math background, if you're just someone who downloads notebooks off of GitHub and tries to make them work. Eventually you're going to run into errors, you're going to have problems, and I used to do that myself. So that would conclude my review. Thank you for watching, and I hope this has been useful to anybody who has been considering learning either reading the book or just learning the math behind machine learning.